Let's try another short one. Let's try this. 2 over x minus 1 is equal to x. Okay, so I want to solve this here. I'm going to multiply both sides by x minus 1. And that gives me that 2 is equal to x squared minus x. So we get 0 equals x squared minus x minus 2. If we want to factor this, looking for solutions with whole numbers, we'll need a 1 and a 2. One of these needs to be positive, the other negative, but we need to have a negative x here. So if we subtract 2x and add 1x, we'll get negative x. Well, a product is 0 when a part is 0. One of the two parts of the product is 0. So I know that x is equal to negative 1 or x is equal to 2. So now what do we have to do? Well, we multiplied by this expression involving the variable. So let's go back to our original equation. Is it okay for us to plug in x equals 2? Well, let's see. If we plug in x equals 2, what are we going to get? Well, this is just 2 minus 1 in the bottom. So that's just 2 equals 2, or 2 over 1 equals 2. That works well. What if we plug in negative 1? Well, don't worry, this is not 0. Minus 1 is minus 2. So we get 2 over minus 2 is equal to minus 1, which also works. So both of these answers are perfectly fine here. I wanted to do an example where we don't have to throw out anything. And this is such an example. Now, if you want to know why we didn't end up having to throw out anything, well, at these two values, minus 1 and 2, x minus 1 is not 0. So we multiplied both sides by numbers that ended up not being 0 in these cases. And since the equation was satisfied after multiplying by those non-zero constants, both of those end up being valid solutions to the question. Now, some of you might have a question about what I mean when I talk about multiplying both sides by a rational expression, or by an expression, which sometimes I've said expression, sometimes I've said rational expression. Let's talk about that in the next video.